So many years ago, I actually had ordered a custom, when I was a younger man, a custom Hamer Californian many years ago. Something like this, not quite. Hamer's no longer in business, or the old Hamer's no longer in business. I think I hear that there's some startup of them happening again. Nonetheless, it was very similar to this, and had some Seymour Duncan humbucker pickups in here, and wasn't quite like this, but had the boomerang 27 fret, excellent guitar, and really missed that thing. And you know, you get attached to something, you learn how to play on it. When I was 18 years old, that was the thing. I mean, I worked for a long time to save it, ordered it custom right from Hamer for myself. And as a young man, I sold it. You know, as young men might make a mistake in life, you needed the money suddenly. And at any rate, so fast forward many years later, can't find them. And if I did, I couldn't afford them now anyway. They're 3 times the price what I paid for it back in the day. But I did find a couple of, like this one is a Korean made, little eBay find, and it's obviously not near the USA Custom. So I have this one, and then I found a middle of the road. This is their Slammer series from back in the day, and I'm not sure where this one was made. Might be Korea. I think it actually might be Japan. So what I did is trying to replicate and get that US feel. I bought a couple of humbuckers and put these puppies in there, and you can see that the bridge, things don't quite line up. I haven't really fine-tuned it yet. I don't know that I will. I would need an F spaced Floyd here for this pickup, and I don't think that the strings on the neck of this, or the width of this neck, can accommodate that. At any rate, you can see they're a little bit off center. I can't get the neck positioned where I want it to, but it's close enough for now. For this particular one, this has got a 3-way switch in it, and is in a little bit of progress. But the reason I decided to do this video is I was going through my stash of things unpacking, and I came across this. And I thought, what in the heck is this thing? So before COVID, I had actually decided that I wanted to try to upgrade this a little bit more. These had the cheap Korean pickups in them, no name brand. So I popped them out of there, and I put in a single rail Seymour Duncan here, humbucker. And I put in another Seymour Duncan that I had on hand. I don't remember which one this is. We'll flip it over and take a look at it later. And I went to wire it up, and I thought, well, let's get a little fancy with this one, and let's wire it out of phase. So what I was looking for was in a 5-position switch, to be here, humbucker, their full humbucker here in the treble position, here 2 outside coils, but then out of phase, and then the center 2 inside coils, here 2 inside coils, then out of phase, and then here the straight up humbucker. And it works okay. It's not great. In fact, the portion that I wired out of phase is not sounding as good as I wanted it to. It's quite a drop in dB, and wasn't too pleased. But I know some people like doing that. It gives a little bit of color and a little bit more dimension to the guitar. But I thought, I want to really have the full power all the way across, because I started to like how this one was playing compared to the other one. So, and tonefully, even though these are just chunks of wood, everyone's going to have their opinion, this sounds more like a Strat to me than the other one does. And I know that it's super Strat, whatever you want to call it, but it has a special tone to it. So I thought, this is worth putting a couple of dollars into. So before COVID, I came up with an idea on how to make the full power of this 5-position super switch come to life. And what I did is I ended up ordering a special custom built humbucker from Seymour, and I had forgotten what the heck it was about. So I had to go back and actually look at what did I do on the order. And in their build your own humbucker section, I chose I wanted it to be just like an HS-16 59 custom hybrid which is 2 different pickups here. And then I wanted it to have the 53 millimeter E to E spacing, so it would match this bridge properly, which is F spacing essentially. And then I wanted it to also be reverse wound, reverse polarity. That's here, RWRP. And what that means is the magnets are flipped around south and north facing in comparison to a standard humbucker in this particular humbucker. So why that matters is when you're going to use, if I wanted to use the full essence of the pickup here, if I wanted to not have them be out of phase, then I would need to have them reversed but still get the humbucking effect. In this position, what I want is I want the bridge humbucker to be in its full power. And here I want the 2 outside coils to play or be active, but then have them have the hum canceling capability within them as well, so they're not out of phase. And then here, this would be full, both humbuckers full straight on. Here, this would be the inside coils, and then again, reverse wound, reverse polarity will give me the hum canceling capability. And then here will be just, you know, the neck humbucker. So that requires me to put in kind of an elaborate switch and an elaborate wiring scheme. How I have it set up right now with whatever pickup I put in here before COVID, I don't remember, is I have these out of phase. So let's listen to what that sounds like. So how can we check to see what wiring scheme I came up with? I can just put a little screwdriver here actually, and I can tap. So right now that's full humbucker. When I come to this position, you can see this coil's active. So the 2 outside coils are active, but they're out of phase. Can you hear that? So here's full humbucker here, and then out of phase. Can you hear the drop in dB, how thin it sounds? And then when we come here to the center position, it's all of the humbuckers, all of the coils rather, and it's powerful. And they're phased correctly. But here, when I come to this position, you see that it's the 2 inside coils, but it is out of phase. Can you hear that? So here's the center again. Here's the out of phase. And then here's just this whole humbucker here. So let's walk through them again. I'll go here. It's all right. The out of phase thing's kind of cool, kind of nifty, but not really going to work for me. So I want as much power and as much clarity out of these humbuckers as I can. So that means that these poles have to be reversed in the north and south facing positions, and then the wounds have to be backwards as well in comparison to here to get this set up. Let's draw this out. I'll show you what I mean. So before we do that, let's take a look at the pickup here. This is a custom build just for me, and I gotta remember what I was thinking and how to wire it. So it is nice cover there. It says SWD Custom Shop Bridge Position, and then it will have their standard wiring color code here. And then inside, you've got a little pamphlet that says all about humbucker models. And then it has a diagram for basic wiring. In this case, this would be like a Les Paul wiring. And again, Les Paul style wiring. 2 volumes, 2 tones. And here we've got a splitting, if you wanted to do a split for the single coil, and then here's a series parallel where you're using a switch as well to do mini toggle switch, and then phase switching here. All very standard stuff, very cool. but none of that will apply because I asked for this one to be reverse wound, reverse polarity. So with that, how are we going to wire this puppy up? Oh, would you look at that? There's an SH-16 already in here. Isn't that nice? That's a great pickup, by the way. Seymour Duncan, made in USA. So here is my old pickup, and for the sake of my brain, I am going to cut that puppy here. All right, so this particular pickup is a standard SH-16. You can look up the specs online, but we're going to see what this one has to offer as far as which pole is north and south facing. So if I bring my compass close to the bottom side of this pickup where the Seymour Duncan label is, you'll see that the north side is facing the bottom of the pickup. So the south side is facing here. So that would be considered normal. Conversely, if I bring the pickup and change the action here, you'll see that the south side is facing the north, right? Because opposites attract. So I can bring it around the opposite direction. We'll get the same result. All right. Now I ordered this other pickup, as we know from my earlier shot, to be reverse wound, reverse polarity. So let's see if it's true. So if I bring this here, we can see that the south side of the compass is facing there. That means the north side of the magnet is facing here. Conversely, if I bring it here, we see the same thing. So the south side is where my finger to the left is and where the compass is. The north side of the compass is facing there. Again, opposites attract. Right, so this is a quick way for me to tell what I ordered. Is it correct? It is. So in this case, the polarity is reversed. Simply that means is if I took the wrapping that is here and I took this wrapping off, we'll take it off on this HS-16. And if you're careful, you can put it back on, but you don't want to rip it, so you got to be very careful on how you take it off. There. So we can go like that. And usually there's just a few. You can see the end of the magnet right here. Now, if I were to undo these screws, these 4 screws right here, I would be able to slide that magnet out and turn it. You could do the same thing if you wanted. This pickup is just fine, so I'm going to disregard that. But at any rate, you can see the wounds that are in there, and you can see where the magnet's at. I'm going to go ahead and reapply this. Doesn't hurt the pickup at all. You can actually buy new pickup wrap if you need it, but I've taken several pickup wraps off, changed the magnets for people in a particular mod. It's not a big deal. At any rate, it's just there to protect the wounds. I don't know if I can get this on camera, but a lot of folks seem to have a problem when they're putting a pickup in, and they have a problem when they're taking the spring and they're trying to compress it into the pickup for this particular style, right? So I'll show you the way I do it. So just put the screw through the bezel and then choke up on the spring all the way until it reveals some of the screw thread, and then just hold it in there with your mighty strong hand. Right there. See that? Spring's compressed, just holding it in. No problems, all right? So then, I'll get a screwdriver ready here. Once you're in that position, then you just drop the screw into the brace of the pickup, let the spring go after you put a little finger pressure on the bezel. And you can see the screw sticking through there. Just start the screw. Don't know what the issue is. I guess, you know, you do anything 10,000 times, you become a master at it. And that's pretty an easy thing for me there. Not that I'm a master, but definitely got my years of changing out pickups. So it's exposed, just a little bit of spring there. And then zip that puppy in right in the center. Hold the bezel steady. Drive the screw home. And then once you're in there, then you just drive it down to wherever you need to. So in my case, I'll use this guy here. Makes things a little bit easier. It's going to get it to a generic height. All right, and always try to use some cloth or something so you're not chipping your finish. And now you don't have to take the strings off. I choose not to because I don't want to waste this set of strings. So yeah, you know, but some people would need to remove all the strings to do this. Absolutely fine, however you need to. But this will be hard to show as well. Try to back the camera out. But try to draw the pickup wire in as you're bringing the pickup through and not touching it to the body. Sneak it underneath. So you're pulling that wire at the same time, gently. And then once it's all the way in there, you kind of got to just feel where it's got to go. And in this case, I'll lift up on the bridge and drop the pickup in there. And then I can pull on that wire a little bit more, make sure she's seated home. And that's it, she's ready to rock. Another mild piece of advice is when you putting the screws back on for the bezel, don't need to really crank them down, you know, get them snug, and snug is enough, you know. If you feel about maybe 1 pound of pressure there, you can see somebody that had this guitar before me, they snapped that bezel. Now, of course, the pickup itself that I ordered custom here, this guy, does come with a bezel, but it's a flat bezel, as to where here you can see this bezel has a pitch to help facilitate the tremolo being high here and the strings pitching down just a little bit. When it's set up, you'll see that. And then I can move this where I want it in accordance to, right? So that's the, we'll go with this one first, and if I don't like the way the pickup sits in there, I can try this bezel as well. So all these pickups come with a lot longer lead than what you need, but because I am a big believer in mods and changing things, I leave the majority of that on. I don't cut it off, but you can break away and get most of this sleeve off if you're careful, and you can take little chunks of it off as you go. Like so. Okay, so now that we know that my pickup is reverse wound, reverse polarity, how have we confirmed the reverse wound? Well, we actually haven't yet. We did confirm the reverse polarity compared to a standard Seymour Duncan pickup. So what we're going to do now is I'm going to take this pickup and the other one, and I'm going to set up a test environment to decide what sounds I want to see out of this particular setup and what I'm capable of hearing. So we'll take all these old wires and we will make a new setup for myself. All right, you guys will probably think I flipped my lid on this one, but I don't know a better way to illustrate this to show you the difference in pickups where there is different sounds that you want to try to achieve, and rather than solder and unsolder and, you know, go through other people's experiments, and, you know, there's a ton of different ways to hook these pickups up, and how do you know that that's the right one for you? You know, you can look at a lot of different wiring diagrams, and you can pick different switches and pots and values and all of that, but at the end of the day, before you start choosing pot values, capacitors and resistors that you can put into circuit to make circuits sound a certain way, you should try to discover what the pickups themselves are capable of doing and how do they sound in their basic configuration. So what I mean by that is, how do they sound if this one's on its own, this one's on its own, and both of them are in parallel with each other, or both of them are in series with each other, or maybe you just want to hear the two outside single coils in parallel or series, the two insides in parallel or series. All of that, all of those individual configurations I just talked about will have slightly different sounds. Some will have drastically different sounds. So this is an easy test fix that I am setting up here, a little fixture, just to try to illustrate how you could go about doing this. Not necessarily a way, but more of a teaching element as well, if you use your ears and hear what I'm trying to discover for you. So what I'm going to do is I'm going to just play with this and see what sounds I can get out of this. So right now what I have set up is I have the instrument is going out and hooked up here to a Fender amplifier, and right now I just have the outside coil of this pickup here. And what I did is I just followed the color code of Seymour Duncan. So if we think about a Seymour Duncan pickup, we have a start and finish. That means the black and the white are this outside rail here, and the green and red are this inside rail here. Conversely, the other pickup, this black and white, is this inside rail here, and the green and red is this outside rail here. So if we listen to the guitar in its current setup, there's no volume, no switches, it's just straight up. So you'll hear a little bit of buzz in the background, and that's okay because the ground, you know, I've got one light ground here to the bridge, but it's not properly grounded because, again, this is an experiment to show you guys and illustrate how this can work for you. And, you know, just a little teaching method. So right now, this is just this single coil right here. And if we look at its own value, see if you can see that in the shot. Let's look at just that individual single coil. 4.3. All right, now let's look at this coil right here. 7.6. Big difference, right? So smaller ohms, larger ohms. Let's look at these two. So the inside one here, 4.6, the outside one, 4.6, identical almost, because that's the design of this pickup, to be in a single coil configuration, but also be powerful and be humbucking, which is its particular design. So, but we can also break that apart and use that with this pickup for a variance of sounds. We could put a three-way switch in here and just have this pickup on full on, this pickup on full on, and both of these in either parallel or series together and have 3 sounds. Or we can have 5 sounds, which is what my intention is going to be here. So when I purchased this particular pickup, I asked for it to be reverse polarity. We've seen that the magnet is turned around. Verified. Good. Now, we want to know that if the wounds are different. Why does that matter? It matters because if you're going to have a humbucking situation, you want both of these coils to be going in the same direction and wired in series with each other to give a hum canceling configuration. So both of these pickups have that, except this one should be in reverse. So conversely, let's just say that all of these wounds on this rail here were going in this direction clockwise. These ones would also be going clockwise to give a hum canceling situation with the magnet inside. And then this one here would be reversed. These would be going counterclockwise, these would be going counterclockwise, but again in series with each other, sitting side by side, sharing one magnet, however. So with that being said, let's listen to just this pickup by itself. So what I'll do is I will bridge the yellow and the red together, and that what that does is that joins those two pickups together. And then I will take the red and green, which is the outside, and now we have this particular instrument in this particular pickup all by itself and here. And in the room right now, it's about 90 dB. So that's what that sounds like. Now, let's listen to just the right side. How do we know it's just the right side? There we go. Now let's listen to just the left side. Sorry about the buzzing, this is just part of the process. How do we know that's the left side? Right? Okay. So now that's that pickup. So we can go over to the other one now. And the way that I have this test fixture set up, let's listen to the whole pickup by itself. So again, I'm joining the red and the yellow to make this pickup be full on to itself. We'll disconnect this pickup. So now we should have here, yes, yes, no, and no. All right, so this is this pickup full on to itself. You can see there's the little drop in volume there, but this pickup has a little bit more of a bassy sound because it's here further down the strings. The strings here, when they vibrate, they have a longer pitch throw back and forth than here. If I move this string from the center, you'll see that where it's moving distance-wise here is a lot less here, a lot more here as I'm moving this, and therefore that change, that distance that the string moves in this position makes this sound a little bit more bassy, you could say perhaps, or wider in a sense. So now let's listen to any combination here. So let's say we wanted to listen to just the two inside. So what I'll do is I'll choose the inside, which is here, and I'll put that on one side. And then we'll choose the inside, which is the red and the green. Get rid of this one. So now if I have that hooked up right, so now we have the two inside coils. So let's listen to those. Huh, well that's weird. We have a drop in volume and it sounds very thin. Well, that only means one thing. They're out of phase with each other. What does out of phase mean in this point? That means the coils are going two opposite directions. So I should be able to reverse one side of the wires, and then that should bring the sound back up. So let's do that. I'll actively hit this, and I'll reverse this. So you can see it's still the inside, but now it sounds a little bit more normal. Okay. All right, so moving on. Let's listen to the two outsides now. So I'll first put them in normal phase. So now this is the red and green on this side. And let's verify what we have. Huh, what happened? Something happened. So if I have red and green, oh, there it is. I missed my pin. So here, outside, yep, outside. All right, so we have the two outsides now, so let's listen. Again, we have that odd sound. It's something doesn't quite sound right. Sounds like they might be out of phase, right? So let's change that, meaning I'll swap the wires on one side. Doesn't matter which side in this particular case for this experiment. Okay. So now we have a normal sound when it's not out of phase. Now, some people like out of phase sounds and they have different purposes for them. I think that's great. My purposes, not really. Don't really have much of a need for that particular kind of sound. So now we have been listening to these in parallel. What does that mean? That means that this one and this one both have their individual connections, as you can see, to the positive and negative of the input of the amplifier, meaning both the positives are going, both the negatives are going, and they're hooked together like this. So what if we were to break them apart, hook them in the middle? That would be called series. So how can we do that in our test environment? What we can do is I can take a jumper cable here. I guess we'll just choose this color here. And what I'll do is I will have one side of the outside pickup go to the other side of the outside pickup, and we'll join the insides. So I'll take the red one out, I'll take the black one out, and then we'll join where the black one goes, and we'll join where the red one goes, and we'll see what we get. Ooh, that sounds nice. So let's see where we're at. Still the outside, but it sounds a little bit more full, and it sounds a little bit louder. After trying several different pickup combinations, I feel that this particular setup for these two particular pickups, the Little 59 Standard by Seymour Duncan, and then the custom shop that I had built by Seymour Duncan, which is an SH-16 that is reverse wound with the magnet flipped, so we have reverse polarity. I feel that in this wiring scheme, these are the best sounds. Now, let's take a look at something. I'll bring this in a little bit so you can see. If we look here, just at the bridge pickup, the individual coils, the north coil, even though this says south magnet, but this is considered the north coil, with the black and yellow wires. In this case, this is actually a white wire. So just take note of one thing. All of the diagrams that I have here, I'm using yellow so you can see it on the white paper, but it's actually a white wire in Seymour Duncan land. As you can see here with this particular pickup, this is a Seymour Duncan SH-16 that is another one, not a reverse wound, reverse polarity, but you can see that the wiring scheme is actually with a white wire there. So that's their wiring code. Yellow is just for illustrative purposes. At any rate, for an SH-16, the inside or north rail has a much higher ohm value than the south rail, and that's indicative of the design. So you can look that up on their website and you can see how the history came about to be wonderful sounding pickup on its own. Can also be very useful in combination with other pickups and splitting and so forth, which I've done here. If we put them in series where the red wire and the yellow wire are connected, we get 12.10K roughly. So these are just rough, if I turn my meter on and turn it back on, off, and then depending on where things are sitting, these values can change very slightly, but sometimes they do. Even depending on if you have a long lead, where you put the clip on the lead, believe it or not, if you have a lot of wire exposed. At any rate, it's another topic, but these are just close approximate values for this pickup that I measured at that moment. So moving on, this would be position 1. Position 2 is where the red wires are connected, and using this green wire here as the positive, this green wire here as the negative. And then the white, black have no bearing on this position number 2. Position number 3 is a high value of ohm because I have them in full series here, and I'm using the longest run that I can get out of these pickups, and thereby making it the most powerful position, or loudest position, if you will, on the individual setup. And but I want some variance, right? I don't want things to sound exactly too much the same. So some people might say that that's too loud. There's ways that you can bring that down so it more corresponds with the other ones, but I don't find the need to do that. Again, this is my setup for this particular guitar. At any rate, you get 21.47K in series for this pickup situation for position number 3. Position number 4, you can see that we have the north rail and the north rail on both of these, and 12.4K when the black wires are connected, and I'm using the white for the positive here and the white for the negative here. And again, in series, 12.4K. And then the final position is position 5, full humbucker, and then 9.4K there. Now, again, I also added the individual coil values. This is standard, so this is the north and this is the south, so the magnet has not been flipped on this, and the wiring is the same. You can see the difference here, right? So reverse wound, reverse polarity means that we've got negative, positive, and then the magnet is flipped to show south and north. On a standard Seymour Duncan pickup, we've got the north here, the south here as far as the magnet is concerned, and then we have positive, negative. So that's the way the standard is. So when you put these two together for series, we get 9.4K. So how do I get all of this? I came up with this crazy little wiring scheme, and let's back this out. You can see it all at once. You can take a shot there with your computer there if you want. There's just gonna get my hand out of the way. And this particular setup is just my own way of experimenting quite a bit. I'll put it right now. I'll put a photo up that shows the wiring in process and trying to figure this out. But at any rate, so let's do it this way. So position number 1, even though they got it marked here for 5, I've reversed it, but that's just, again, my way. So even though it says 5 here, I'm using this as 1. So we could put a value of 1 here if we wanted to where the 5 is. But if we don't look at the numbers, we just say that the toggle switch is in this position all the way over to the right. That means that these two blades are connecting these two blades, and these two blades or poles are connected to these two poles. But this is a switch that has 4 individual poles. So this is pole 1, pole 2, pole 3, and pole 4. So if you take a look at it, they're actually separate. So in this position number 1, we look at my wiring diagram, we can see that this, and this are connected to both here and here. These are on all the time. So if this and this are connected, if we look at the green, we know that for this position number 1, the positive itself needs to be on the positive side. So the green here goes here, positive, out. That takes care of the green wire. The red and the yellow need to be tied together. So here's the red and the yellow, and as you can see, here and here, they're tied together here. And then finally, the black wire, which is here, goes to negative. So if we look at the black wire, that goes here, and in this position, it's tied to negative because we see that this particular position here is tied to negative. That's position number 1. Position number 2, if we look at it, is here. So now the blades move over, or the pole positions move over rather, and we can see that these two are connected, these two are connected, these two are connected, and these two are connected. So what does that give us? Because I wanted to have the red wires here connected, I need to then have this be my positive, this be my negative. And as you can see here, this is positive and this is negative. So it corresponds, really easy to set that up. And in order to do that, we have the individual positive, again, being tied to here, the green wire here, staying positive. And then we want the red and red tied together. So here's our red that comes up to here. Here's our red that comes up to here, tied together. You can see that tied together. And then finally, we want that green to go to negative. So because we are on this particular switch right here, the green is going to negative here. Or to ground, rather, we could say, right? Either way, same difference in a sense. So position number 3, we're split right in the middle of these 5, right in the middle, connected to the 2 outsides. And what I wanted in this one is I wanted the black ones to be connected. That sounds great, very powerful. And so what I did is I have the green, of course, now again in the center going back to the positive. And then I wanted the black ones to connect. So if I gave this one a primary position, the black here, I can have connected this one, which has a jumper that connects here. And then that ultimately gives me connection back here. So you can see that this is one black wire that comes off this position here for the neck pickup. And then that ties to here, and another physical jumper, a black piece of wire, connects these two poles, and then another physical jumper connects these two poles, thereby giving me this one, when this one is active, connection to this one, thereby connecting the two black poles. The two black wires. And then, of course, my negative again goes to ground. Position number 4 is changed now. You can see that the white wire is positive and negative, but I need the black ones connected again. So very easy. The black ones are just connected. Now we're in position number 4. So that means we are, position number 4 is denoted here. These two are connected to these two. These two are connected to these two. So position 4 means that the black wire again is connected to the black wire here. Done. And then how did I achieve the white and the white wire now being responsible for positive and negative? This is why I actually added this switch, because if we look at it, we can see that the white wire here that is to be positive comes to here, and in this position, when this is position number 4, it is connected to positive. Great, so that takes care of that. I need the black ones connected. We just talked about that. But this one has to go negative. So if we count over, we're actually on this position. You can see where now the yellow one here, which is actually white for Seymour Duncan, and just yellow for my illustrative purposes, is for this position tied to ground. So that's completed. But in order to truly get these two north poles working in unison together, I needed to be able to split. So this coil is only working because in the, if we look here, it says position number 4, north with switch up, switch down, full neck and north bridge. So when this volume knob on this dpdt switch is pushed in the down position, you have the full neck position plus this north facing coil. And I wanted it to be able to do this. So it gives me an extra position. So I can have both of these live plus this one live. And then if I flip this up, or pull it up rather, you can see that it pulls this to ground. And then what happens is that true ground completes that circuit for here. And then this essentially gets turned off, or in this case actually grounded the opposite direction. At any rate, you can have that position be this way with this pulled up. So we'll get into the individual switch positions here shortly. And then finally we have position number 5. Position number 5 is now negative and positive, and then the two centers tied together. So if we look at that here, we can see position number 5 is these two tied together and these two tied together with these two. So you've got 4 and 4 tied together. And this is, again, my position number 5. You could just flip-flop the numbers to think about it. It can work either direction, doesn't really matter. I chose to go this direction. At any rate, so how do we achieve number 5? So number 5 comes about by having the negative here, of course, be the negative. And then the red and the yellow need to tie together. So here you can see that the yellow jumps here with a physical jumper. And then that connects here to here. So that gives me this connection. Now this has to go to full positive. So in order to do that, the black one here goes here to full positive. So in the down position, it's full neck. You could, if you want to, then I call this a practice position, because this particular little 59 has such small K values individually, 4.7K, 4.7K, not necessarily always intended to be split, but in this case works very well. But this pickup by itself is a little bit weak. and so it drops quite a bit in dB level. But so I could say, yeah, use it as a practice coil, you know, or if you have another purpose. But at any rate, you're still getting a sound nonetheless. And I couldn't find another way to achieve this schema without having this dpdt in place to be able to get me the ground in these two positions that I needed. So if you do pull this up, you will only get this north coil at 4.7K, and it will be quiet, but it's still functional. And it's not, in this case, going to be hum canceling because it's this coil by itself. So that said, let's go through the notes here. We can see here that in position number 1, it is full bridge in series with switch down, switch up, full signal, kill, switch, action. So why that is because in this particular situation, when I had position number 1, I have a negative on this side and a positive on this side. If we pull this up, it grounds out this pickup. And that acts as a kill switch. I think that's a great feature to have. But it only works when the switch itself is in position number 1. Great. And position number 2 is south-south. And of course we can see the photos here. The black ones are denoting what is active, and the white ones are inactive or not active. I have a little typo here, by the way. We'll get to that. With the switch down, south-south, and switch up, no effect. Fine. In this particular case, there's not a way to make a function there, so good to go. Position number 3 is the neck and bridge full series with switch down, and then switch up full bridge with neck coil split north hot. That means that this one is then split, the north is hot, you got full humbucker here, and that gives you that position. I could have denoted that here and called it position number 4, but you get the point with the splitting, right? The splitting really is just so I could get all of this and finally get this pickup and finally get this position actually working. The other ones are just kind of bonuses to be able to split that pickup, I think. At any rate, moving on. Position number 4, north-north with switch up, switch down, full neck, and north bridge. So again, I wanted to be able to get this aspect with the north-north. Great sound because this is a 7.2K north-facing coil right here, because this is a 7.2K north-facing coil combined with the north-facing coil of 4.7K gives me a great sound, even though that 4.7K is close to this one, but because of timbre difference and the length where the pickups are magnetically, they sound quite different and gives you that added bonus sound. So then, of course, position 5, full neck in series, neck only with switch down, switch up, we get that coil split, and that's the north hot coil. I just made a couple of notes here. I said, keep in mind when I'm describing above, north, or south, I'm using normal Seymour Duncan speak. The black pickups denote inactive coil, the white inactive. That should all be one word at any rate. This setup is for normal wired and magnetic pull pop, meaning pickups in the neck, and for reverse wound, reverse polarity in the bridge. The volume push pull is a 500K. That's this pot right here. And you can stack tones, etc. around. What I mean by that is you can take this signal out and you can put a tone pot here and then tie it to your jack if you wanted. For this particular guitar, I don't like using a tone pot. I just like having switch capability, and I get my tone from my amp and my pedals. So the approximate values, this is just a little bit of a repeat, but to show the final positions that correlate here without the splits, not talking about the splits, just talking about these positions as highlighted. All positions are hum canceling theoretically. I say theoretically because, again, we can split this and have a single coil here. And with that, by itself, it's obviously not hum canceling. And then in certain other combinations, we have one side canceling, one side not. So theoretically, most everything except for that is hum canceling. But it sounds absolutely excellent. So with that, that's a whole lot of information you probably didn't want to hear about, but for those that are interested in how this sort of thing works, I think it's valuable. All right, so here's the actual wiring, and that could have been done a little bit cleaner, but again, it's in process to make sure that it's going to work for me. And you can see the connections that are in there, and but you can follow the diagram to get the same result. That can be wired and clean up a lot more, and I'll do that at another time. But for the moment, just to illustrate, we'll do a little bit of sound here, just real basic. Hopefully we're somewhat in tune. All right, so here we go with just a quick sound denoting. So this is position number 1. The switch is all the way here, and this is the full bridge in series with itself, just a humbucker. How do we know? Good to go. So if I go here and I pull that up, that's a kill switch. Now, if we go on to number 2, we can see that we have south-south. So there's number 2, and we can check that by saying yes, no, yes, no. Comparatively, great. Position number 3 gets a little loud here. And position number 3, we can also use the split. So we can pull this up. So in position number 3, it's full on pickups, and then with the switch up, the full bridge, and I'll show you that here. So for position number 3, it's all of the coils, and when we pull that up, we can see that this one is live, this one is not, even though you're getting a little crosstalk. Hear the difference, right? And then full on, full on. So that's that position. Position number 4, basically my favorite position outside of position number 2, is in the north-north with switch up. So when the switch is up, we have north and north. Yeah, north, north. And that gives us this sound. And then down, that brings up the full humbucker. So down, good to go. And then finally, full neck in series and neck only with switch down, switch up, coil split, north hot. So that's here. When this is down, this is the full humbucker. And we'll go, good to go. And then we can split it. You can see that dB drop because only this small 4.7K coil is active. So this is just crosstalk you're hearing. So that is a usable position. I'd say it's a practice position, or just don't use it. You know, either way. But it's an option for you. So let's hear them side by side. So here's the bridge. Kill switch up. Position number 2. And position up does nothing on this one. Position number 3. And then split. Position number 4, and then the 2 norths. Position number 5, and then the north split. All right. So if you enjoyed this, I never say this, but subscribe, thumbs up thing, whatever. You know, I don't do this YouTube thing because I need 5 billion people following me. This is just for education of people that are interested in unique things. That's all, in electronics. At any rate, just a hobby thing for me, not out trying to make some famous something or other like some folks do. Everyone has a different motivation and prerogative. At any rate, take care. See you next time.